Hello students, welcome back to Algebra 1B. Today we're going to do part 2 of factoring polynomials, which is entitled Factoring Special Polynomials. Now, in this case, I wouldn't exactly call them special, but there are a few situations that pop up that you should be prepared to deal with. So, just in general terms, the quadratic trinomials that we have been factoring have looked like this. A times x squared plus b times x plus c. Now, to put a finer point on this term right here, the ax squared, is called the quadratic term, while this term here that has the variable is called the linear term. And then this term at the end, that's just the plain old number with no variable on it, is called the constant. Now, I do feel like it's worth pointing out that we have not done a problem with an a value on it. Actually, we have done a problem with an a value on it, but in every one that we've done, we've been able to factor that out. So what if we can't do that? That's going to come up in a future lesson. We won't deal with that today. Every trinomial that we've done has had all three of these terms, though. So the thing that I want to talk about today is what if we're missing one? So let's go ahead and start one. What if we are missing the constant? So if we have something like this, x squared plus 3x. Now there's two different ways we can go about this, and I'll show them both to you. The first way is to ask yourself, if the constant is missing, what is the constant? What number can go right here without changing it? And hopefully you're looking at it and thinking, that's 0. So I could say that this is x squared plus 3x plus 0. And then I can use the same technique that I've been using. I can go ahead and use my area model right here. This is x squared, this is 0, this is x and x. And now I need to think to myself, what two numbers can I put here and here so that they multiply times 0, but then these two corner boxes are going to add up to 3x. Now this is an easy one because anything times 0 is 0. So I could put 0 here and then literally any number over here, and it would multiply together to equal 0. However, I need them to add up to 3, so I'm going to use 3 and 0. So that means that this would be 0x and this would be 3x. They multiply to get 0, but they add up to 3. So this would be, for an answer, x plus 0, x plus 3. Except we don't ever write plus 0 because it's plus nothing. So I would just simplify it to x and x plus 3. Now the second way that you could do it is to look at x squared plus 3x, and you could look at this and notice that there are x's in both of them, and simply factor the x out. So this is like reverse distributive property, doing the distributive property backwards. So I notice that there's an x in both of them, so I can factor the x out. And if I took an x out of each of them, what would be left? This one would be x, and this one would be 3. And I get the same answer in, I think, a lot less work. The thing about this one is that it does require you to remember to do that, where the one that I've done in pink here is doing it the same way that you always do, just adapting it to a different scenario. The other situation that we have is, what if we are missing the linear term? So in this case, this would be something like this: x squared minus 16. Well, what I want us to remember here is that the linear term is missing. So if the linear term were here, I would have x squared and negative 16 here. And then think to yourself, what would the linear term be if it's missing? Just like the constant term, it would be a 0, but it would be a 0x. So now I can go ahead and proceed with the same factoring technique. Here's x squared and here's negative 16. I can say, okay, this is going to be x and x, and now I need to think of two numbers that are going to multiply to give me negative 16, but I need these two corner boxes to add up to 0. So if I look at 16, 16 could be 1 and 16, or it could be 2 and 8, or it could be 4 and 4. So there's the one that I want right there, because if I put a 4 here and a 4 here, well, that would multiply to positive 16. So in order to make it a negative 16, I would need one of them to be negative. So that would give me negative 4x and positive 4x. Those add up to 0, which means my final factored answer is x minus 4 and x plus 4. And that is how we factor special trinomials.